3.1 Symmetry and Coordinate Graphs. Our objectives for today are 1. Use algebraic tests to determine if the graph of a relation is symmetrical, and 2. Classify functions as even or odd. Okay, so basically we're going to pull from what you've already learned in geometry. You should understand what symmetry means from geometry. Maybe just looking at lines of symmetry, understanding what, folding a figure, understanding both sides of a line is symmetry. Now we're actually going to algebraically test to prove that symmetry does exist. Okay, we actually have 6 different tests, which is going to be a lot to memorize, but you got to know them. Okay, we definitely use this in calculus. Definitely use this in college algebra for those of you that are going on to college next year. So the first test is of the origin. Now these first 2 tests deal with a function and deal specifically with the second objective, classifying a function as even or odd. So given a function f of x, if f of negative x is equal to negative f of x, and we are going to create those. That's the test. We have to find f of negative x and negative f of x and compare them. If they are equal, then the function is symmetric with respect to the origin. And we can classify it as an odd function. Okay, so that's the test that we're going to apply. Probably a lot more there than it really is. It's not much work. You're going to see it's a very simple test. And then at the same time, we are going to test number 2, symmetry with respect to the y-axis. Again, given a function, f of x, if f of negative x, again, we have to create that, is equal to the original function f of x. If those 2 are equal, then the function is symmetric with respect to the y-axis, and we can classify it as an even function. It's going to take a little bit of time to copy those down. Anybody still copying? Yes? Everybody's good? Okay, so these are the 2 tests that we're going to apply to this example. We are to determine if the graph of f of x is symmetric with respect to the origin or the y-axis. Okay, so this is our test. Graphically, we look at the curve, and in geometry, you'd probably say, oh, it looks like I could draw a line of symmetry here or a line of symmetry here. We're going to test very specifically the origin and the y-axis. To test the origin, it said that we were to compare f of negative x and negative f of x. We have to create those and then compare them. So how do we find f of negative x? What do we need to do to create that? Good. Well, no, I want specifically f of negative x. If this is f of x, x to the fifth, what would f of negative x be? Which is just a substitution. Correct. Negative x to the fifth. We're going to replace x with negative x. That's all that means. And any negative raised to an odd power stays negative. So we can say that f of negative x is equal to negative x to the fifth. Now we have to create negative f of x. Well, the negative's out in front of the function, so we're simply going to put the negative out in front of the function up here. So it's negative of x to the fifth. We then multiply, and we get negative x to the fifth. Are these two equal? I can see people nodding. Yes. Yes, they are. Our test said that if f of negative x and negative f of x are equal, then we can say it is an odd function and it is symmetric with respect to the origin. Now, if you find that it is symmetric with respect to the origin, you don't even have to consider the y-axis. Because if it's yes for the origin, it's definitely no for the y-axis. If we were going to check for the y-axis, what we would check is f of x and f of negative x equal? So is the original and f of negative x the same? No. And you expected that because it worked here. So it's a very simple test. Are these two equal? Yes, it's odd. If these two are equal, that would be even. We're going to do two more of these. Question?
Okay, so since it's with respect to the origin, it's odd.
Yes, exactly.
The other one is a B.
Yeah, look back here at the notes.
Okay, I wasn't sure if it's opposite.
Right here. If it is true, this is true, then it's odd. If this is true, then it's even. All right? So let's take a look at B. Here's another function. Again, we will test f of negative x and negative f of x. Everywhere we have an x, we're going to replace it with a negative x. So this x becomes a negative x. This x becomes a negative x. Clean it up. Negative x over 1 minus minus, or 1 plus x. Negative f of x. Put a negative out in front of the original function, x over 1 minus x. Now when we distribute that negative, how do we do that? How? In front? We could do in front. That's true. Okay. If I was going to move it into the fraction, where do I put it? Nope. That's exactly what I was hoping you would do. You distribute it to both top and bottom, right? If you put a negative on top and a negative on the bottom, that's two negatives, which is really what? Positive, which is not what we're distributing. When you distribute a negative, you can only put it on the top or the bottom, not both. So I prefer to just leave it on the top. All right, so that's negative f of x. All right, so let's compare here. we're going to compare this and this. Are those two the same? Let's look. Yes or no? No. So it's not odd. Now, we're comparing the original and f of negative x. Are those two the same? No. So it is not even. So we'll say it's neither. Okay? Neither. It's not even, it's not odd. So we can't classify it as one of those. Any questions? Got one more. Make sure it's completely clear. Are you ready for the third one then? Okay, then part C. F of x equals x to the fourth plus x squared. Again, I need to find f of negative x and negative f of x. And everywhere we see an x, we're going to put a negative x. So that becomes negative x to the fourth, negative x squared. Any negative to an even power becomes what? Positive. So this is x to the fourth plus x squared. Negative f of x. Negative in front of the entire function. Now what do I do with the negative? A little louder. Distribute to both. Negative x to the fourth minus x squared. Here's our test. Are these two the same? Are these two the same? No. So it is not odd. Are these two the same? Yes. Therefore, it is even, and we can say it is symmetric with respect to the y-axis. Yes? No.
So if you kind of first one, would you have to explain like the work?
Technically, no. If I was asking you, is it even or odd, and you see immediately that it is even, you don't even have to check the odd. I was kind of going in reverse order so that you had to. All right? But yeah, absolutely. No, that's a great question. It cannot be both even and odd. It has to be one or the other or neither. Good question. Any other questions? Okay, that was the first two tests. We did 4 more. Okay? All right, what happens if you're not given a function? If you don't have f of x? Does every graph you look at have to be a function? Is a circle a function? Is it? Does it pass a vertical line test? No way. A circle is not a function. Okay, but it has many lines of symmetry. Okay? So it doesn't have to necessarily be a function in order to test for symmetry. This is probably a little bit more similar to what you did in geometry last year. You had a graph, you had some kind of curves. Oh, where's the lines of symmetry? They don't necessarily have to be a function. X-axis. If you're given an equation, not a function, you are to replace y with negative y. If the new equation is the same as the original, then it is symmetric with respect to the x-axis. Okay, so it's a test for symmetry. You have to memorize it. Think of it as an exercise in self-discipline. Don't be lazy. You got to memorize it. Okay? I'm telling you, you will have to know them in calculus and college algebra. Again, there's a lot of writing here for a very simple test. You'll see when we get to the example. All we're going to do is replace y with negative y. If it's the same as the original, then it is symmetric with respect to the x-axis. The fourth test is symmetry with respect to the y-axis. If you're given an equation, in this case we replace x with negative x. If the new equation is the same as the original, then the graph of the original is symmetric with respect to the y-axis. One last time, x-axis, replace y with negative y, y-axis, x with negative x. Okay? That's what you got to get in your head. Anybody still copying? Good. There's two more. The fifth test. The line y equals x. Given an equation, you're supposed to replace x with y and y with x. If the new equation is the same as the original, then the graph of the original is symmetric with respect to the line y equals x. That's big time when we get to logs, exponentials. Talking about inverse functions now. If you have symmetry with respect to the line y equals x, okay, the function in its reflection is the inverse of that function. Okay, that's something we will be studying here in the future, finding inverse functions. The log function is the inverse of the exponential. And graphically we'll show you how that works. And number 6, y equals negative x. These are very similar. Replace x with negative y and y with negative x. See if it matches the original. If it does, it's symmetric with respect to the line y equals negative x. Again, these are just tests. You can test for symmetry. That'll tell us more about the equations in the future. About the time that your hand starts cramping up because you've been writing so much. Right? I know it's not English class, but we do write occasionally in math. I actually had a class in college, and all we did was paragraph proofs. That's it. It was a whole semester of paragraph proofs, writing them over and over and over again. So mathematical analysis was the name of that class. So you guys are getting off easy here. I'm going to slide this down a little bit. Is everybody okay with the first one? Y equals X? Leave it there. Examples at the bottom. Yes. I'm actually going to ask you to do all of them. In the homework, the second half of the homework, you're going to be asked to do all 4 of those tests. The first half of the homework, you're going to be asked to do just the first 2 tests. So that's why I broke them up that way in the notes. Okay, so you'll be asked to do all 4 and ask if you got any of them to be symmetric. Okay, so we're actually going to perform all 4 tests. Does that make sense? We're going to do it right now with this example. Is everybody good on copying here? So we're ready to start the example? Yes? All right. Here's our equation. Determine if the graph of xy equals -2 is symmetric with respect to the x-axis, y-axis, y equals x, and y equals -x. We're going to test for all 4 things. Okay? So let's start with the x-axis. Now what are we supposed to replace with what? I'm going to put a little side note here. Y equals -y. So here's my original. I'm now going to replace y with -y. That's my new function, or my new equation now. It's not a function. Clean it up. I get -x, y equals -2. And I'm going to try to make this look like the original. So I'm going to multiply both sides by a -1. So this becomes xy. So is the original and my result the same? No. So is it symmetric with respect to the x-axis? No. That's it. That's all you do. So that's the x. Let's do the y-axis. What was the test for that? X to -x. Okay, here's the original. And now I'm going to make a substitution. X becomes -x. -xy equals -2. Again, I'm going to multiply by -1 to try to make it look like the original. And I get these 2. Are they the same? No. Is it symmetric with respect to the y-axis? No. Okay. Let's test some more. Y equals x. That's pretty self-explanatory. It's right there. Y becomes x, x becomes y. So here is the original. I'm going to put it in a different color. Okay, x becomes y, y becomes x. You follow me on that? Now in this case, it really doesn't change much, right? If we had a different function, say like x squared plus y equals 2. If x became y, and y became x, that would be very different. Okay, so that's exactly what we're doing here. But because of algebra, we're allowed to switch these, right? So, are these two the same? Absolutely. Yes. This is symmetric with respect to the line y equals x. We're going to look at that here in a calculator in a second. Well, think about it. What would the line y equals x be? It's a line, right? Where is the y-intercept? Origin. With what slope? 1. Up 1 over 1, up 1 over 1. So 45, cutting right through the first and third quadrant, which we're going to show you here shortly. So that picture, whatever this is, should be symmetric on both sides of it. It should be a mirror image. Good question. Last one. Y equals negative x. Again, I'm going to replace, in this case, x with negative y and y with negative x. Okay? Multiplying this out, I get yx equals negative 2. I'm allowed to switch them. xy equals negative 2. Are they the same? Yes. So we are symmetric with respect to the line y equals negative x. So that's what you have to do. Questions? I want to look at this graphically. Definitely. Glad you brought that up. Is everybody okay with the algebra part of this? This is the last example. Let's climb back up here and basically put this equation in a different form. In order to put this into the calculator, I have to have y by itself. So I am going to divide both sides by x, and I'm going to get negative 2 over x. Do you agree with that? Right. Let's take a look at it on the calculator then. Okay, I'm going to go to y equals in the calculator. Now I'm going to put in my equation. Negative 2 divided by x. And then we're going to look at the picture. Zoom 6, standard zoom. So basically the graph is here and here. This is a simple hyperbola. Okay, I don't know if you've ever heard of hyperbola or not before. Rational functions, graphs are hyperbolas. Okay? It's stuck in quadrant 2 and 4. Eventually we'll talk about vertical asymptotes, horizontal asymptotes. You will actually be able to graph this by hand. Probably about a month. No calculator. Okay? So if we look at the x-axis, if we flip this, will we get the same picture? If this gets flipped up top and that gets flipped down, is that going to be the same as the original graph? No. Y-axis, if we flip it around the y-axis, will we get the same thing? No. See, a lot of you know it. Now, let's look at the line y equals x. If I flip over that, will I get the same thing? Absolutely. And we proved it already. It says that we should, and looking at this graphically, we flip across that, we are going to get exactly the same thing. And if we check y equals negative x, okay, let me change the zoom one tiny little bit. I'm going to go to a square zoom. That might look a little bit better. If I flip across that line, will it be exactly the same? Yes, it will be. Okay, and we proved it though, algebraically. All right, just physically looking at it though, same thing. there any questions on symmetry or proving it? Yes. For these, yes. That's how you test the symmetry. Because what's symmetric mean? In geometry, fold the paper, are they laying on top of each other? Yes, so they have to be the same when you flip across or fold on top. Mirror image. So yes, it always has to be. Now the other one doesn't. That was with function notation. It's a little different. Okay. Anything else? Okay, that's it for the